Alright, so in this lesson we're going to be doing systems of linear inequalities. The beginning of this is going to be pretty much identical to what we did in the previous lesson. We're just going to have two inequalities in one problem, right? So if you recall with systems of equations, right, we had two equations in one problem and we had a solution, and on a graph that was where the lines intersect, right? Now, in a system of linear inequalities, we have a similar idea of we want to graph them in this xy plane. And this time we're going to see where the overlap is. So if you remember, we want to shade the area in which we have solutions for a line, or sorry, for a linear inequality. And so if you have two linear inequalities in one graph, right, hopefully you can imagine that you would have several areas that are shaded, right? And the solutions we call the parts where they're overlapping, right? And you're going to see what I mean in the next slides. But for now, let's just do some refreshers on what we did in the previous lesson. So the first step in all of these is always to try to get the y by itself, right? So we want it to look like a slope-intercept inequality. And so for something like this, all we have to do is subtract 8x on both sides. And then we end up with y is less than negative 8x plus 6. All right. Next one, similar idea where we want to get the y by itself. So I'm going to subtract 3x on both sides, and then I get negative 2y is greater than negative 3x plus 10. And then we want to divide by negative 2. All right, so let's divide everything by negative 2. And then if we remember, what happens when you divide by a negative? Right, I briefly talked about it in the previous video, but this is also from way back. Anytime you multiply or divide by a negative, you flip the direction of this inequality symbol. So it's going to become y is less than. And then negative 3 over negative 2 is going to simplify to positive 3 over 2x. And then 10 divided by negative 2 is negative 5. All right, so that's all we have to do for that one. Right, now we have y by itself. All right, and then the last one here, we want to actually graph the solutions of this inequality. All right, so the first thing we want to do, as always, is to get y by itself. So I'm going to subtract 4x on both sides, and then we get 3y is greater than negative 4x plus 9. All right, and then we have a 3 in front of our y, so I'm going to divide everything by 3. All right, so I get y is greater than negative 4/3 x plus 3 divided by, 9 divided by 3 is 3. All right, and then if we remember, right, this less than is going to tell us two things. One, it's going to tell us that it's going to be a dashed line, right, because it is a strict inequality. And then the second thing is that we know that it's going to be shaded above. So it's going to be dashed and then shaded above, right? So I'm going to plot the point 3, right, because that's our y-intercept, right? So b in this case is 3. Our slope is going to be negative 4 over 3, right? This is in slope-intercept form. So I'm going to go down 4 to the right 3, and you end up with another point. And then I told you with these to draw a couple points, right? Enough so that enough so that you get a clear idea of where it's going, right? Especially in this section, right? Because you might, I don't know, towards the end of it, let it trail off a bit, and maybe you get a little bit messy with your line, right? So you want to make sure that you're graphing it accurately, especially in these systems of linear inequalities. So you get a dashed line like that, and I know that it's going to be shaded above because it is a greater than. Right, so something like that. So then, like I said, the objective in this lesson is to graph and solve systems of linear inequalities in two variables. So similar to what we did in the previous lesson, just now we have two inequalities in one problem. All right, and these are some terms that you're going to hear me say quite a bit throughout this lesson. Now, a system of linear inequalities is a set of two or more linear inequalities containing two or more variables, right? Just like a system of equations, right? If you remember a system of equations, if I had y equals 2x minus 3, and then maybe I had like, I don't know, x plus y equals 5, right, our solution to this was going to be, we had an intersection of these two lines, and they've met at a point, a single point. Or if they were the same line, then they would have infinitely many solutions, or they were different lines and they had the same slope but never touched, right? So parallel, no solution. In a system of linear inequalities, we have something similar, except we're gonna, I don't know, get rid of that equality symbol, and it's gonna have something like, I don't know, greater than or equal to, less than, right? So we're gonna see the similar setup, just with inequality symbols instead of equations, right? All right, so now I'm going to first determine what a solution of a system of inequalities is, right? So first thing I'm going to do is I'm going to plug in -1 for x and -3 for y. So this is our system of linear inequalities, right? You see y and x in this single problem. So what I'm going to do to determine if it's a solution, it needs to satisfy both inequalities. So I'm going to go ahead and plug in -1 everywhere that I see the x, and -3 everywhere that I see the y. So I get -3 is less than or equal to -3 times -1 plus 1, and I want to see if this is true. So I get -3 is less than or equal to -3 times -1 is 3, plus 1, and 3 plus 1 is 4. And I get -3 is greater than 4. This is true, it works. But we're not done. We have to check the other inequality as well. It needs to satisfy both. All right, so I'm going to go ahead and plug in a -1 where I see the x and a -3 where I see the y. So I get a -3 is less than 2 times -2, or I'm sorry, -1 plus 2. All right, and that's going to get us a -2 plus 2. And then I get -3 is less than -2 plus 2 is 0. All right, and this is also true. So I'm going to say yes. The ordered pair is a solution. All right, let's try the exact same thing for this one. Plug in -1 where I see the x and a 5 where I see the y. All right, so we get 5 is less than -2 times -1, and then I get 5 is less than 2 minus 1, so I get 5 is less than 1, and this is not true. So if it's not true for this one, I don't even need to check the second one, because if it doesn't work for one of them, then it's not a solution, right? That's that. So this is not a solution. All right, and this was the same remark that I had just mentioned, right? It needs to work for both inequalities for it to be a solution. All right, so now to show what the solutions are, right, remember, an inequality is a little bit less restrictive in terms of solutions, right? You can have many solutions in one single inequality, right? Unlike a system of linear equations where you just had one single solution if the points, if the lines intersected. In this case, if your lines intersect, you don't just have one solution, you have an entire area of solutions, right? So if you look at these two examples, right, example 1a, example 1b, we see that we have overlapping regions here where these two inequalities meet. So I'm shading it in purple now. So this entire area, I can pick any point in here and it would be a solution. If you plug it back in, then you'll get a solution to the inequality. Same thing with example 1b. I can shade every single part of this overlapping region, and everything in here, if you plug it into the system of linear inequalities, you'll get that it works as a solution, right? So even though parts of it are shaded, so you can see that this point right here, 2, 0, it works because it's in the blue, but it doesn't work for the red, so this one wouldn't be a solution, right? Same thing, I can pick a point right here, maybe through 0, 3, right? Clearly it works in the red region, right? But it's also not in the blue region, so this one wouldn't be a solution, right? A solution is anything that's in the overlapping region. All right, so we're just gonna graph these. I'm gonna go one at a time, right? So this first one is y is less than or equal to 3. Well, remember, we see a line in the middle, so it's going to be solid. And it's less than, so it's going to be below, right? Less than is below. The line underneath is a solid line. So I'm going to find 3 on the y-axis. This is a horizontal line. It's going to look something like that. And then we have a shaded region. This entire region is our shaded region. Right, so looks something like that. And then our other one is going to have, this is in slope-intercept form. Our slope is going to be -1. We can write that as -1/1 so that it's easier to graph. And then our y-intercept is 5. All right, and because it doesn't have that line underneath, it's going to be a dashed line. And because it is greater than, it is going to be shaded above. All right, so I'm going to draw this point right here, 5, and then -1/1. It's going to have points going down like that. All right, and then you can go in the other direction as well. It's just to kind of help you out, and then you can sketch your dashed line. And it's going to be shaded above. Right, so it's going to be this entire region that's shaded. Now, what's the part that's overlapping? Well, you can see that the part that has both blue and the red is this region right here. So this part of your graph is going to have your solutions, right? And our directions also say give 2 ordered pairs that are solutions and 2 that are not, right? So I'll start with the ones that are not, right? Ones that are only in the blue, I can pick one right here. All right, so 0, 0. So I'm going to say non-solutions. 0, 0, right? You can see that it's in the blue region, but it's not in the red. Similarly, I can pick one in the red that's not in the blue right here. That looks like it's about, looks like it's at 3, 7. It's in the red, but it's not in the blue. I can pick one that's in neither, right? So -8, 6, right? It's in an area that's completely unshaded, right? So that's not going to be a solution anywhere. Now I can pick solutions now. All right, so let's say solutions are going to be anywhere that's in the purple. All right, so I can pick a point. I kind of whited it out a bit, but I'm going to pick a point right here. All right, that looks like it's at 5, 2. And then I can pick another one. I'll just go 1 over, right? 6, 6, 2. Also keep in mind, I can pick something that's on this blue line, right? So I could pick like 10, 10, 3, right? So 10, 3, my drawing's not that great, but you can see that we have a solid line right here. If it's on a solid line, it is a solution, right? It wouldn't be a solution if it was on a dashed line. So you can see right here, 5, 0 is also a non-solution because even though it's on that red line, our red line is a dashed line, meaning that any point on that line is not a solution. All right, so these are just some examples. All right, let's keep going. So again, the first thing you want to do is make sure that all of your inequalities are in slope-intercept form. This first one is not in slope-intercept form. So to get it in slope-intercept form, I'm going to add 3x to both sides. So we end up with 2y is greater than or equal to 3x plus 2. And then you want to divide everything by 2. So I get y is greater than or equal to 3 over 2x plus 1. All right, and so since this is a inequality that has the equal sign underneath, it's going to be a solid line. And because it is greater than, this is going to be shaded above. All right, so our slope is going to be 3 over 2. Our y-intercept is going to be 1. So I have a 1, and then a 3 over 2 is going to be right there. All right, I'll just make a couple more points. Doesn't have to be that many, but right, just so that we can draw the line a little bit more accurately, right? Since here it matters a little bit more. Right, so you get a line that looks something like that. And we know it's going to be shaded above since it is a greater than. Right, so it's going to look something like that. I won't go too crazy with it since we're going to need to see some points. The next one is already in slope-intercept form. So we have a slope of 4, a y-intercept of 3, right? It is a strict inequality, so it's going to be dashed. And it is less than, so it's going to be shaded below. All right, so I'm going to have a 3 right here. A 4 is going 1, 2, 3, 4 up, 1 over. I can do the same thing in all the other directions. All right, so I get 1 right there, 1 right there, 1 right there. All right, and then we get a dashed line. And I'm going to shade below. So something like that. And our area of solutions is going to be this area right here, where they overlap, right? So that's going to be our solutions. So picking two solutions, or no, picking 2 points that are solutions, you just want to make sure that it's in the purple region, right? So I have a 2 right here and a 5 right here. So 2, 5 is a solution. So I can say solutions 2, 5. And then maybe I'll pick one on the line, on the blue line, right? So 4, 7, right? That's a solution. It's a solution because even though it's on the line, it's a solid line. On the solid line is a solution, right? And then some non-solutions, right? I can pick one on the red dashed line, right? Because it's a dashed line. If it's a dashed line, you can't have any points on it as a solution. So 1, 7, it's on the red line, but it's a dashed line, so it's not a solution. And then you can pick just any other point that is not in the purple region. I always like to check if 0, 0 is one because that's the easiest point to look at, right? And as you can see, it's not in the blue region, it's only in the red. But then you can look around, you can probably find a couple more, right? Just draw some points and decide, right? So these points, random points that I'm plotting are non-solutions, right? Because none of them are in the overlapping region, right? So that's all you have to do for these. All right, do the same thing with this one. First one is already in slope-intercept form. Our slope is 1. You can write that as 1 over 1. Our y-intercept is 1. Because it has that line underneath, it's going to be solid. And because it is less than, it's going to be shaded below. All right, so I'm going to have a y-intercept at 1. Up 1, over 1 is just going to be going up along this diagonal. And I can go backwards like that as well. All right, and then just connect these points. It's a solid line, so you can just draw a continuous line. And this one's going to be shaded below. I'm going to use the highlighter on here. I know in Notability you guys probably have that feature, but let me try it here as well. But just keep in mind on a test or a quiz, if I'm asking you to shade the region and you don't have a highlighter or anything, you might need to use your pencil and shade it. All right, so there's our shaded blue region. And then our red line, hang on. Okay, our red line is going to be a horizontal line. I know that it's a horizontal line because I only see a y and I don't see an x. Because it is greater than, it's going to be shaded above. And because it is a strict inequality, it's going to be dashed. So dashed above is what I'm going for. And our line right here starts at 2, a y-axis, on the y-axis at 2. So then I'm going to draw a dashed line, and I know I'm going to shade above. All right, so then I'm going to get the highlighter again, and I'm going to shade everywhere that's above this line. And then you can see the overlapping region is right here, right, that I'm shading right now in purple. All right, so this is our overlapping region. So this is where we have our solutions. All right, so picking 2 points that are solutions, you can pick a point, I don't know, it doesn't really matter right there. So solutions, I'm going to say that point is 7, 5. And then another point, you can pick one, again, on the line is fine. As long as it's a solid line, you can have one on that line. It's going to be 6, 7. Another one could be, I don't know, that point right there. It's going to be 4, 3. And then non-solutions, anything that is not in that shaded purple region, right? So I could pick one right here, 2, 0, That's one of them. On the dashed line as well. So I can pick one that maybe looks like it's in the overlapping region, but it's on a dashed line. So that's not a solution. So 6, 2 wouldn't be a solution. I don't know, a point right here in the red, but not in the blue, is going to be 3, 7. All right, so those are examples of solutions, non-solutions. All right, and that's all we're really doing in this entire section, right? So that was it for this lesson. What you guys need to know is that a solution, even though I'm shading everything, the solution, what your graph would look like is you need to make it very clear what the overlapping region is. Otherwise, you would just erase everything that's not shaded, right? So let me erase everything over here. So all of this, like for example, if I give you something that's a multiple choice or something and you're looking at, okay, well there's only one shaded region, it's the one that's the solution, right? So this right here would be the only part that's the solution. You can leave the rest of it on there if you want to, right? But as long as you make it clear that the solution part of it is this part that has your overlapping regions, right? So as long as you know that that's solid, that's dashed, and that this is the area that has your solutions. All right. But otherwise not too different from what we did in the previous lesson. We're still just graphing linear inequalities and just picking points, putting them in, and determining if they're solutions or not. All right.